So for today, we're going to talk about the polar form of a complex number, and this is still a part of our Advanced Engineering Mathematics lecture. Okay, if you are new to my channel, please don't forget to subscribe to my YouTube channel for more videos of lecture all about Advanced Engineering Mathematics. So let's get started. So the polar form of a complex number. So if we are again to recall the complex number, it is actually represented by z. Okay, and that is equal to x plus iy, which means that the I here is the imaginary number, which is equal to negative of square root of 1. And then we have x and y as real numbers, any real number. So we can represent complex number as this. So this is in rectangular form. So 1 plus I, 2 minus I, 1 half minus 0.5 I, that is in rectangular form. So how do we get the polar form of a complex number from the rectangular form? So if we are going to consider this triangle below in an organ diagram, so we have the x-axis as the real part, okay, the real part here of our complex number, and we have y as the imaginary part. Okay, so that we have positive real number here on the this one, and then negative. We have positive I here and negative I here. So if we are going to draw, okay, let's say that we have a complex number in the form of x plus iy. So if we are going to plot it in an Argand diagram, so let's say that is this complex number represented by the coefficients of x and y. So what are we going to do is that we have a certain value of x here, okay, the real number, and we have a certain value of y number here in the quadrant 1. So it forms a triangle. We know that this is the x, this is the y, and what we actually want to get is the what we call the r, okay, where r is r and theta represents the polar coordinates of the point x and y in the rectangular form, and r is what we call it is always a positive number. It is the length of the vector representing the complex number z. Okay, this r. So we know that by Pythagorean formula, we can get r simply by the square root of x squared plus y squared, since this is a right triangle. So that's how we get r, the length of r. Again, r is a positive number r. It represents the length of the vector of the complex number z. So how do we get x and y? We can get x and y by having cosine theta and sine theta functions. So for cosine, we have adjacent over hypotenuse, that's x over r. And we have, for sine theta, we have opposite over hypotenuse. So that is y over r. Getting x and y, so we have x equals to r cosine theta, and our y would be r sine theta. Okay? So polar form can be represented by the following. So given these equations, so we know that z is equals to x plus iy. So what will happen here, since x now will be equal to r cosine theta, we replace that, this x, plus we have, of course, we have the I, that's the imaginary number, and the y, we have r sine theta. Of course, we can factor out r because it's common. So cosine theta plus I sine theta. And this will be our polar form. Okay? Our polar form of complex number. That is our polar form. Okay? So how do we get this theta? Meaning this theta, we can get that theta by getting the tangent function, tangent theta, that is opposite over adjacent. If we wish to get the theta, that is theta arctan, okay, y over x. So technically, this would be our formula, but not all the time this will be used. Okay, because what if the x would become 0? Okay, in such cases that the x would become 0, meaning we don't have any real part. Okay, here the value of x is 0, so this would be undefined. So that only means that the angle is actually in the 90 degrees here, okay, or pi over 2 or negative pi over 2. That would be our angle. In case that the y would be 0, so arctan would be 0. Okay, that's the first case. So the angle would be 0. Or again, if the complex number is negative, okay, in here, so what will happen? It would be lying on this part of our uh, argon diagram. Okay, so as we go on solving this formula, or using this formula, solving some rectangular form, converting it into polar, we will be tackling more about that. Okay, so theta will be always in, it's best to express this in radian. So it's best to, if you're going to use your calculator, it's always best if we are going to use that, or make it in mode, radian mode. Okay, so let's try to solve some problems involving how are we going to convert complex numbers into its polar form. We know that this is in rectangular form, 1 minus I. So how do we convert this into polar form? So the solution for this is that we are going to convert or get the r first. Again, the r is the square of sum of the squares of the square root of the x squared plus y squared. In this case, our x here would be 1 squared, okay? The coefficient of x here, and then we have plus the negative 1 squared, the coefficient of the imaginary part. So we know that this should be square root of 2. And that is the length of our vector, the positive length of our vector, r. We get the r. So what do we need to get also is the theta, which is equal to arctan of the y over x. We know that our y here is actually negative 1 over 1. So that is simply the arctan of negative 1, which is negative pi over 4. So this is still correct, okay? Because we know that this rectangular coordinates lies in the fourth quadrant. This is in the quadrant 4. Why? Because this is a positive value and this is a negative value. It lies on the fourth quadrant. So this angle, though it may be negative, is still correct. So the negative only means that the angle is measured in clockwise position. Okay? Measured from the positive x. The theta, I forgot to tell you that the theta is always measured from the positive x. That is our reference. Okay? So our answer here would be negative pi over 4. Or it can be also, okay, 3 pi over 4. Okay, 3 pi over 4, or the supplement, I think. Okay? Okay, negative pi over 4. I think we can also get the angle in the counterclockwise direction, and that is 7 pi over 4. Which is correct. But the calculator gives you negative pi over 4, so we are okay with that. But we can also use 7 pi over 4 as our answer. Okay? So if we measure it counterclockwise from the positive x. Okay? So that is the answer for that. So if we are going to express this polar rectangular complex number into polar form, it should be this. The r, okay? The cosine of negative pi over 4 plus I sine of pi over 4. And again, square root of 2 is common. I forgot square root of 2 here. Let me just rewrite this. This should be r also. I sine of negative pi over 4. We can factor out square root of 2 because it's common. So we have cosine of negative pi over 4 plus I sine of negative pi over 4. So this is our polar form for our answer in number 1. Again, if the complex number lies in the quadrant 4, okay, so we can measure it okay, clockwise or counterclockwise from the positive x-axis. Okay, for our second number, number 2. So we have number 2, we have to get the polar form of negative 1 half, okay, minus square root of 3 halves I. Okay, so square root of 3 halves I. Okay, so again, this is pretty straightforward, formula based. So we have to get the R. So we have negative 1 half squared plus a square root of 3 over 2 squared. And if we are going to solve that, that's only equal to 1. Okay? Then we get the theta of the arctan of the negative square root of 3 over 2 over negative 1 half. So as you can see, the 2's will cancel. So we are left with the arctan of square root of 3, because negative square root of 3 over negative 1 should be square root of 3. Okay? So that results for your calculator in pi over 3. Remember that your calculator always gives you the acute angle. Okay? It is always an acute angle. But the theta here is incorrect. Okay? So the theta here is incorrect. We need to still identify first what quadrant does our complex number belongs to. So we have a negative and negative, that's in quadrant 3. So if it lies within quadrant 3, upon getting the theta from our calculator, okay, we need to add pi or subtract pi from this, because as we can see, this is our pi over 3. It's our pi over 3. Whereas, if we are going to analyze this complex number is in here. Okay? So, what are we going to do is simply, we need to add it to pi. Okay? Or subtract it to pi. Okay? Add to pi or subtract to pi, doesn't matter. So, we do here, it's more convenient to add pi. Okay? It's your call. Okay? So, if you subtract pi, this would be the angle. Okay? Okay, so the answer here will be 4 pi over 3. Or if you did pi over 3 minus pi, that is still the same. Okay, as you will be in this coordinate or in this quadrant. Okay, so what will happen if you use minus instead of plus pi? So you will be leading to negative 2 pi over 3, which is the same. Okay, so the polar form of this, you can choose one. So we have, so negative 1 half minus square root of 3 over 2i is now equal to r, which is 1 cosine of theta. So cosine of 4 pi over 3 plus I sine of theta, that's 4 pi over 3. Oops, we also have 1 here. Okay, so but it doesn't matter. Okay, so that I'll delete the 1 here because it's understood. Or it can be cosine of negative 2 pi over 3 plus I sine of negative 2 pi over 3. So, okay, that is actually our answer for number 2. So for me, I always use, if the complex number is located in quadrant 3, I always use a minus pi, but it's still the same. So for the rest of our example, if the complex number is located in quadrant 3, I'm going to subtract it from pi. Okay, so let's try again another number. So for number 3, okay, we have the z is equals to negative 1. Okay, it's a complex number. It so happened that y has no value. So let's say if we get the polar form of this. So upon getting, we know that that is negative 1 squared plus 0, because it does not have any y value. So that's our r is still 1. So our theta, that's arctan of y over x, 0 over 1, that is arctan of 0, okay, which is actually 0. So upon calculating with the calculator, it turns out that the angle is 0, but it is not. If we are going to plot it, so this is our negative I, this is our positive x-axis, and this is negative 1, and this negative 1 is located here. Okay, and if we are going to measure the angle with respect to the positive x-axis, that is not equal to 0. That is simply equal to pi. Okay? That is simply equal to pi. If measured, okay, our definition of theta is the angle from the positive x-axis. So this is our negative 1. So, our answer here should not be 0, but rather, okay, it is actually pi. Okay, the angle is actually pi. So, in order for us to get the polar of this, that is r cosine of pi plus I sine of pi. 1 I sine of pi. Now, let me just rewrite this. Even though we did not write 1, it's okay. But still, I'll write 1 here. Okay. So, we know that sine of pi is simply equal to uh, 0. So, we can leave it as it is. So we have cosine of pi plus we have I sine pi. Okay? If we are going to evaluate this, this is simply equal to negative 1. So this is the polar form for our answer in number 3. So how about for number 4? Let's try it. Negative 2i. That's our complex number. So we get the r first. So our r is 0 squared plus negative 2 squared. That is simply equal to 2. Okay? We get the angle theta, arctan of y over x. Our y is negative 2. Our x is 0. We cannot calculate this. This results to math error in your calculator because the denominator is 0. That is math error in your calculator. But upon observation by inspection, if you're going to uh, graph negative 2i, this may be the negative 2i, okay, negative 2i. So it's located, okay, if we're going to measure the angle of this, okay, either from this, from counterclockwise or to clockwise, okay, we know that if we measure it from counterclockwise, okay, or clockwise here, from the clockwise here, it is only equal to negative pi over 2 or negative 90 clockwise direction from the positive x-axis. Okay? So, we can also measure it here, okay, from the positive axis, and that would be 3 pi over 2. But let's get this, negative pi over 2. So, our answer in this question, negative 2i, if converted into polar form, that should be 2 cosine of negative pi over 2 plus 2i sine of negative pi over 2. So in other words, we can factor out 2. We have cosine 2 multiplied by cosine pi 2 plus I sine of negative pi over 2. Okay, this shall be our answer for this problem in converting this complex number into its polar form. So for number 5, we have z is equal to 2 minus I. Okay? So it's very simple. We get the r first. That's 2 squared plus negative 1 squared. Okay? That is square root of 5. Okay? So that is square root of 5. Our r is square root of 5. Our theta would be arctan of negative 1 over 2. So if we get that in our calculator, that's negative 0.464. Okay? So it's correct. Okay? Take note that the negative here only means that it is measured, okay, in clockwise from the positive x. Clockwise direction. So clockwise direction. Okay? So that's negative 0.464. Okay? Not exactly in my drawing, but it's actually located here. That's our theta. It's our theta. Okay? So if we are going to analyze, z lies in the quadrant 4. Okay? So we have the positive x, okay, and the negative y. So it lies in the quadrant 4. So we know that this is correct, okay, because we know that if the angle reaches here, it should be negative pi over 2. And negative pi over 2, okay, if we evaluate that in decimal, that's negative 1.571, approximately in 3 decimal. So negative 0.464 is less than this. I mean, if we neglect the negative number, okay, which is still this should be correct because it is less than this, okay, than this, because it is this angle, okay, this angle is located at quadrant 4, which makes our answer correct. So I hope you are able to get that. So our answer here for converting 2 minus I into its polar coordinates, that would be square root of 5, okay, cosine of negative 0.464 plus I square root of 5 or square root of 5I sine of negative 0.464. We can factor out square root of 5 so that we have cosine of negative 0.464 plus I sine of negative 0.464. And here is our answer. Okay? So let's try another problem. Okay? So by the way, if you evaluate this, this should be equal to 2 minus I. If that is not equal to 2 minus I, then our answer is not correct. Okay? So 6 would be negative 2 plus I. That is our complex number. How do we convert this into polar form? So we have R is equal to negative 2 squared plus 1 squared. So that is still equal to square root of 5. Our tangent or our theta would be arctan of 1 over negative 2. Which in turns, okay, which turns out, I mean, that it is still equal to negative 0.464. But if you are going to notice, this complex number is located in second quadrant, quadrant 2. Negative x but positive y, that's in quadrant 2. So what are we going to do is to simply add pi, okay, plus a pi. So if we do that, okay, if it is in quadrant 2 plus pi, okay, just like what we did a while ago. So we add pi, so that is 2.678 in 3 decimal. So 2.678, that is our correct angle because we know that this is measured, theta is measured from here. Okay, so we have to add pi. Okay, so okay, this should be our answer. It's greater than pi over 2, which is equal to, in this case, this should be positive. Okay, because this one, if the angle is in this one, that's positive 1.57. So we have this answer. So again, if we get the uh, the polar form of this should be square root of 5 cosine of 2.678 plus I square root of 5 sine 2.678. Since square root of 5 is common to them, that is square root of 5 cosine of 2.678 plus I sine of 2.678. This should be our answer for number 6. Okay, so for number 7, it's pretty much the same pretty much the same example. So we have negative 2 minus I. So how do we get that? So we have R, we have negative 2 squared plus negative 1 squared. Take the square root of that. That is still square root of 5. And how about the theta? We have arctan of negative 1 over negative 2. That's arctan of 1 half, which it turns out to be 0.464 positive. But let me remind you that our complex number is located at quadrant 3. So this angle is incorrect because 0.464 is in the first quadrant, which is here only. So we have to find the angle here. So if we get 0.464 here, okay, we can get let me just redraw this. This is our angle 0.464 in terms of radians, but our angle should be located here. Okay, so we have to add or to subtract pi here. Okay, since this is in quadrant 3, we have to subtract pi here. Okay, so that's what I'm telling you a while ago. Okay, that if it is in quadrant 2 plus pi, if it is in quadrant 3 minus pi. So if we subtract pi here, so we get negative 2.678, such that if we are going to write the polar form of this, it should be square root of 5 cosine of negative 2.678 plus square root of 5 I sine of negative 2.678. Square root of 5 is common to them, so we have square root of 5 factor of square root of 5 cosine of negative 2.678 plus I sine of negative 2.678. So this should be our answer for this problem. So again, just take note if it is in quadrant 2 plus pi, if it is in quadrant 3, okay, minus pi. So for quadrant 4, it can be either plus or minus pi if the angle that your calculator gave you is not correct, okay, or not correct in terms of the quadrant or the angle. Okay, so let's try the last example for number 8. So for number 8, we have z is equal to I'm so sorry, this is second to the last. Okay, so we have z is equal to 3/4 negative 1 half I. Okay, so get the polar form of that. So our polar form would be r 3/4 squared plus negative 1 half squared, and that is equal to square root of 13 over 4. The angle theta, arctan of negative 1 half y over x over 3/4. So that would be in simple terms, we have 4 over 2, so that would be negative 2/3. The arctan of negative 2/3 is negative 0.588. Make sure that you are in radian mode. Okay? So this negative 0.588 is correct because this is in quadrant 4. Okay? This is correct because this is not greater than the pi over 4, pi over 2 itself, or 90 degrees, 1 point or negative 1.57. So this is now correct. Okay, so this is now located, if we are going to measure it counterclock or clockwise, as negative 0.588. Because if we extend the angle here, 90 degrees, that is pi over 2, which is negative 1.57. So it is still correct. So the answer that we have here is correct. So we can now therefore write its complex form. Our r here is square root of 13 over 4. Let me just factor it out. Okay, so we have cosine of negative 0.588 plus we have I sine of negative 0.588. So this is our answer for the polar form for this problem. And I hope you learned something for today's video in converting a simple rectangular complex number into polar form. And I hope to see you again on the next video. Or if you are new to my channel, please don't forget to subscribe and check out my playlist in Advanced Engineering Mathematics. Okay, and again, okay, a simple reminder before we close. Okay, if the complex number is located in quadrant 2, we add pi. If it is located in quadrant 3, we subtract pi. If it is in quadrant 4, we can either add or subtract. So, thank you so much for listening. I hope you learned something today. Again, this is Engineer Abat. God bless you.